Greetings and welcome back. Today we'll be doing a summary video which goes into the possible relationships between molecules. So we had structural isomers, and then we had two different flavors of stereoisomers, but I want to provide you with a framework where given two molecules you can start to kind of tease out what their possible relationships could be and indeed what their exact relationship is. So I like to think about this as kind of a flow chart. So let's say we have two molecules, A and B. And starting with those two molecules, the first thing I would ask myself is, do they have the same molecular formula? And if the answer to that is no, then they're not isomers at all. And so we might say that these guys have no relationship. But if they do have the same molecular formula, then they are isomers. From isomers, we can break this down even further. So the next thing I would ask myself is, are the bonds in the same place? So if the bonds are in the same locations, then we have two possible situations. If the bonds are not in the same location, then they are constitutional isomers or structural isomers. Put in here conformers. And so conformers exist when you, yes, have the same molecular formula, but no, the bonds are not in the same location. And in general, if the bonds are in the same location, and you have the same molecular formula, either they're identical, and I'm not going to put identical on here because I think you can figure out what identical is. So yes, if the same bonds are in the same location, and they have the same molecular formula, they are most likely going to be either identical or stereoisomers. All right, and then let's split up stereoisomers. So stereoisomers have two possible kind of outcomes based on the question of, are all chiral centers switched? So that is going from R to S or S to R. And if yes, all the chiral centers are switched, then we have enantiomers. Make sure I have enough room here. Enantiomers. All right, so that's a possible relationship. And if they're not all switched, then we have diastereomers. And so those are our possible relationships. I would say that you should go through isomers, but isomers should never be your answer because it's incomplete. Likewise, stereoisomers should not be your final answer because it's incomplete. If they're stereoisomers, you need to figure out, are they diastereomers or enantiomers? No isomers or no relationship is a possible outcome. It happens rarely. Well, actually it happens all the time, but that's pretty much the easiest one to figure out, besides the possibility of just basically, are they identical? And this is a possibility. So I'll ask here, are they the same? Question mark? Yes? Then they're just identical. And hopefully that one's a little bit obvious. So those are the this basically works out to be a multiple choice question, where if you're given two molecules, they can be identical, or they can have no relationship. And then we need to kind of work through the question of, Are they stereoisomers or constitutional isomers? And if they're stereoisomers, are they enantiomers or diastereomers? All right, I'm going to give you a couple questions for this with correct answers, but this is something that, obviously this is not a lot of video, but this is something that you really need to work on. This kind of summarizes everything that we've done over the course of the last 4 videos, but this is going to be a big question. This is going to be what your outcome test is all about, is just given 2 molecules, what's the relationship between them? So this is something you definitely need to practice. Thank you very much, and I will see you in class.